This is Mishu and welcome back to my YouTube channel. So in this tutorial, we are making a project that is how can we remove the green screen from videos and add a background on this green screen. So if you are new in my YouTube channel, so please do subscribe my channel and must hit the bell icon because in every week and daily basis, I have written some videos regarding machine learning, data science, artificial intelligence, Android development, and so on. So let's jump on our project. So let's have a look our folder structure. So how it actually look like. So this is our folder structure. So as you can see here, there a picture called bg1 in png format. This is the background image as you can see before. This is the video for corona and we are going to use that, and I collect this video from the Google. And this one is the test video. I actually record this video using my mobile phone camera. So I'm going to open the Visual Studio Code. So now if you wanted to actually implement this project, you need to do some installation. So first thing first, you need to install Python in your local machines, and also you need to install a library called opencv. So just open your command prompt and type here pip install opencv-python. Okay, so I already installed this library in my local machine, so I'm not going to install it again. So I'm going to click here to create new empty Python file. So let's say main.py. So now we need to read the video from our folder. So we are going to use the opencv. So let's import this one, import cv2. So it's same in real time also. Just you need to put here a part of the video expecting the 0 or 1. So now I'm going to create a video capture frame. So video capture. So inside this parameter, we are not going to use 0 or 1. So now in this case, we're going to use the part of the video. So main.py file is actually in the same folder, whatever it's instituted in the main test.mp4 file. So I'm going to put here the part of the video. So while true red frame. So now we're going to read the video. So you can see a red frame. So red, it take the boolean value. So if the boolean value is 0, that means if the video path is correct, so it will return 1. But if the video path is not correct, so it will return 0. So if it will 0, so the infinite loop 2 will be false and the infinite loop will be black. So now we need to put here the I am show. Okay, so inside this you need to put here the window name. So let's put here the frame as it is same and frame, and also you need to put here a white key. Okay, so white key, and you need to put here 1. So let's put into a variable. So k equals cb2.whitekey 1. So if anyone press q from the keyboard, so this infinite loop will be black. So black video, okay, not b, video dot release, and finally we're going to destroy all the window, destroy all windows. If I going to save the code, Ctrl S, and going to run the code again. Now you can see here it's our frame, okay, but the frame is so bigger. So now we need to resize the frame. If I press Q from the keyboard, so this frame will gone. Okay, so we are going to use cv2.resize function to actually resize our window. So cv2.resize, and inside this parameter we need to put the source. So our source should be the frame, and the d size, it will be tuple, so the height and the width of the video. So let's say 640 and 480. Let's save it, Ctrl S, and I'm going to run the code again. So now you can see here our frame is look like so good. Okay, frame is okay. So now we need to read the also the picture from here. Okay, so let's put in the variable image cb2.imread, and inside this need to put here the path. So our path is bg1.png. So now we need to do same as it is in the images. Ctrl C and going to paste it here, and let's make it at image, and also this one image. So when we remove the green screen from the videos and we replace the green screen via our picture. Okay, so now talk about the technique, which technique we are going to use. So first thing first, we are detecting the green color from our video. So after detecting the green color, we are going to replace this color in a background. Okay, so in this case we are not we are need to create a mask. So after creating mask, we need to convert our frame into ASSB color format. So cb2.cbt color, so it will take the parameter of the frame, and cb2.color bgr to HSB. So now we need to convert this frame into ASSB color space. We already do that. So now what we need to do, we need to create a mask. So after creating the mask, we need the value of the green skin. That's mean the lower value and the upper value. So if I go here, so max equal to cb2 dot in range. So in cb2 there is a built-in function called in range. So it will take the argument for the source. The source should be the HSB, but what will be the lower bound value and the upper bound value. So you need to collect that. So there are some predefined value. You can find the value from the Google. You can search it from here, but we are going to use a technique to actually collect the lower bound value and the upper bound value. Okay, so you're going to use trackbar. Okay, so I already make a videos what we call shape and color detection using opencv in Python. So link in be in the I button and also in the description. So I already discussed about that in briefly in my videos. You can also check it out here, but I'm not going to explain what will be the trackbar in opencv details, because in my opencv playlist I already uploaded so many videos regarding opencv and I already discussed about that. So you're going to use trackbar to actually collect the lower bound value and the upper bound value of the color. Okay, so now we need to initialize the window name. So name window, and what will be the window name of the trackbar. So our window name shall, let's say, trackbars. Okay, trackbars. And now we also need to resize the trackbar window here. Okay, so let's put here the window name. So window name should be again the trackbars, and let's put into the weight and the height. So weight should be 300. Let's say what height should be 300. Okay, so now we need to create the trackbar. So let's use this method to create the trackbar. So we need to put here the trackbar name. So we need 6 trackbar, but why? Because we convert our image BGR to ASSB. So that means hue, saturation and the volume. So for each hue, saturation, volume, there should be 3. That's mean for lower and the upper. Okay, so let's initialize is for the lower hue, and what will be the window name. So our window name, we are going to use this one, trackbars. Ctrl C B, and now I need to put here the value. So what will be the value? So the lower HSB actually started from 0 to 179. Okay, and what will be the unchanged? Let's say nothing. Okay, so you need to do same as it is in the 6 for 6. Okay, so I already do that for the time consuming. Okay, you can see I already do that code before. Okay, so I'm going to just copy it from here, and I'll explain what will be what will actually happen in this code. Okay, so create a trackbar for the low hue, low saturations and the low volume, and the upper hue, upper saturation and upper volume. So trackbar 0 to 179. So the hue started from the actually the low hue value actually started from 0 to 179, and the saturation actually started from 0 to 255. As you know, in the RGB image, okay, or HSB color space, their upper value should be the 255. So you need to do for the upper case should be started from the 179. That's mean it is the lower value, and this one should be the upper value. So upper value will be same 179 to 179, and 255 to 255, and 255 255. And unchanged, you need to put here just nothing. Okay, and you need to create a function for that. Okay, so let's get grab nothing, and it don't take any parameter, and let's put it a pass. Okay, so now you need to actually what do you call actually get the position of the trackbar. Okay, so now you need to get the position of the trackbar. So cb2 dot get trackbar positions, and it will take some parameters. So what will be the trackbar name? Okay, so this is our trackbar name. If I go here, okay, this will be the trackbar name. So first one is the trackbar name and the window name. So I'm going to copy it here, Ctrl C, and going to paste it here. So let's put in the variable, let's say LH, okay, L underscore H, okay, this is for the LH. So I already do that code here before for the all cases. Okay, I'm going to paste it here. Let's format it. Okay, so as you can see here, LH, LF, LB, UH, UF, and the UB. Okay, so now we need to convert these actual value into numpy array. Okay, so let's say L green equal to np dot array. Okay, so we need to also import this numpy here. I'm going to go up, I'm going to import numpy as np, and I am going to convert this into numpy array. Okay, so this should be the lower hue, okay, and okay, not this one, lower hue, and the lower saturation, and the lower volume. Okay, it's also same for the upper green equal np dot array, same upper H, upper what do you call, upper saturation, and the upper volume. And let's put here the L green and the upper green. Okay, if I try to show the marks, I am show, and let's say this one marks and marks. Okay, I'm going to save the code and run the code. Okay, this is our marks, and this is our frame, and this is our trackbar. Okay, so if I do the changes here, as you can see here, this is the white and this is the black. Okay, now we are going to convert this image here. So you can see here, this is the value for the lower value, low saturation, and the low volume. That means this should be the black. Okay, this should be the green. Okay, that means this is your binary image right now. So our low value and the low hue, low saturation, low volume, low and upper hue, upper saturation, and upper volume. So we need to collect the value from here. Okay, then it will say look like that. So now we need to again come back this frame. That means we need to convert the frame. That means the white should be right now green. We need to convert this frame again the green. Okay, then we can change the background. So let's make it back here. So we're going to use cb2.bitwise operator, bitwise and inside this it will take some parameter, source 1 and the source 2. So which will be the source and the 1 and the source 2. So our source is nothing but the frame and the marks. And now okay, not should the frame, that should be the frame again, and you need to put here the marks. If I go here, you can see your source 1, source 3, DST, and the marks. Okay, DST is none, marks. So now we need to put here the marks, marks equal marks. Okay, yep. So if I try to print it out also in the pop-up window, so I am show, and let's say this one should be the res, and going to put here what we call res. Okay, Control S, and I'm going to save the code and run the code again. So this is the res. As you can see here, this one will be frame. Okay, so now here is the trackbar. This is our trackbar. Okay, so let's change it. Okay, you can see here this image should be in black. Okay, this image is black, but the green screen is not removed. So now we need to collect the green screen. That means we are going to subtracting, or you can say minus from the actual frame to the resolution frame or res frame. Okay, you can see here. Okay, yep. So this is the upper value and the lower value. Okay, I will also collect this value from here. Okay, so I'm going to press Q. Okay, so what will be the lower value green and the upper value green? Okay, I'm going to create another variable for that. For using this trackbar, we can actually got this value. You can see here for the lower value I collected before for 32, and this lower value 44 maybe, and this one should be the 132, and not 42, that should be the 94. I collected before. Okay, you can also using the trackbar to actually collect the value from here. It's also different in some cases. You can also use red screen, yellow screen, whatever, but you need to collect the value from here. So 255 and the 255. If I am going to comment out this line and I'm going to save that and run the code again, now you can see here. Now you can see here, this is our marks, and this is our ref. Okay, you can see here, this is the actual frame and this is the binary image right now. Okay, so now we need to actually remove this green screen from here. So now we can subtracting from the frame to the resolution, then we can get this only this image. Okay, I'm going to press Q to row that. Okay, so f equal to, now we need to remove from the frame to what will be the marks or res. So we are going to subtracting minus them from the frame to res. That's mean our actual frame, we are going to minus the actual frame to the resolution frame. Okay, if I going to print or try to show the frame f. Okay, if I go here, okay, let's say make it also f. Okay, going to save that and I'm going to run the code. So now you can see here, this f is nothing but this one. That's mean f means we are successfully remove this green screen from the background. So now you can see here only me here. Okay, I'm talking here, and now we need to actually replace this black screen to the images. Okay, now you can see here correctly. Okay, so call. Okay, you can see here image and the call. I'm going to press Q. Okay, so now if I try to also print the value of f, okay, Control S and run the code. If I go here, you can see here, this is the actual matrix which containing the value of 0. Okay, 0 means this is the black portions. If I go here, you can see here some value is nothing but started from okay, go up some value, you can see here 100, 123, okay, something. Okay, you can see here the value is nothing but here. If I go up, you can see the value 31811840. So this value is nothing but our images. So our images is converted into numpy array. So now if we found the 0 from our images, we are going to replace this 0 by our images. Okay, so now let's replace it. So let's say green screen equal and p dot higher. Okay, so it will take the condition first. So what will be the condition? So if our frame will get the matrix of 0, we are going to replace this frame into the image. So image and the f. Okay, so if I'm going to save that and going to run the code, let's say green screen, and let's say make it green screen. Let's save that and run the code. So now you can see here, this is the marks. Okay, let's minimize that, and this is the trackbar. So we don't need the trackbar because you already use the trackbar to actually get the value from here. So you can see here this image actually replaces the background from the green screen. So cool, but something is happening because my camera resolution is not so good, so that's why. Okay, but if I going to use the image of corona one, it will be give me the better accuracy, but it will also good. Okay, for the copyright issue, I am not going to use this one. I think it will be heavily from the copyright issue, because I collected this video from the Google, and I already upload a post in our community box yesterday. So as you can see here, it is the actual community post from I actually posted from 22 hours ago. So this is the actual result. For the copyright issue, I am not going to use this video. So this output is actually look like, and I'm using another background. So you can see it's also cold, and you are going to use the trackbar to actually get the lower SSB and the upper SSB from here. So this is the video. Hope you will enjoy this tutorial, and make sure to subscribe my channel, and don't forget to hit the bell icon for never miss an update.